log of 1 plus x divided by x. Here the base is e, and the value of e, that is Eulerian constant. E is the symbol of Eulerian constant. We have to split here into two limits, minus limit x tends to 0 e to the power minus x minus 1 by x. I write the numerator keeping in mind the standard form, e to the power x minus 1 divided by x equal to 1. Now I am going to take few more standard limits, rather more standard limits. First one is limit x tends to 0 e to the power x minus 1 divided by x, that is equal to 1. Second one is limit x tends to 0 log of 1 plus x divided by x. Here the base is e, and the value of e, that is Eulerian constant. E is the symbol of Eulerian constant, and value of e is it lies within 2 and 3, an irrational number. And the last form is limit x tends to 0 1 plus x whole to the power 1 by x, value is e. Also its alternative form is limit n tends to infinity within brackets 1 plus 1 by n to the power n. Actually, if we put x equal to 1 by n, we get this form. These are the three more standard limits, and on these three forms I have taken first for this form few sums. Now let me solve. Number 1, limit x tends to 0 e to the power x, as this involves e to the power x, therefore the standard limit to be used here, limit x tends to 0 e to the power x minus 1 numerator divided by x is equal to 1. For that I write this limit in this form. For the standard form, e to the power x minus 1 divided by x, I am getting this part. Then I have subtracted here 1 and also subtracted another minus 1, like this. Then limit x tends to 0 e to the power x by x. We have to split here into two limits, minus limit x tends to 0 e to the power minus x minus 1 by x, and this value of this one is 1, minus, here we find minus x is there, in place of x there is minus x, that means we have to change the variable. What will be the change? Let x equal to minus y, therefore y tends to 0 as x tends to 0, therefore it will be limit y tends to 0 to the power y minus 1 by minus y, because x equal to minus y. Now I take this minus with this one, 1 plus limit y tends to 0 e to the power y minus 1 by y, that means the standard limit. Therefore, value is 1 plus 1 equal to 2. I think students have followed this one. My suggestion will be, while you are following these classes, you take your practice copy and pen and you work out with me. Then you will learn first. Then I move to the next one, number 2. Number 2, given limit. First you copy the limit in your copy. Limit x tends to 0. I write the numerator keeping in mind the standard form, e to the power x minus 1 divided by x equal to 1. This one will be e to the power 13x minus 1 minus e to the power 7x minus 1 divided by x. Here you see, if we simplify this expression, minus 1 and it will be plus 1 will be cancelled out. Therefore, now we can write as difference of two limits. Limit x tends to 0 e to the power 13x minus 1 by x minus limit e to the power 7x minus 1 by x. Now I note e to the power 13x minus 1 is there. Therefore, we have to change the variable. We can do now by writing 13 here into 13. I write like this, 13 into 13, and here 7x into 7, and 13x is there. Therefore, we have to write here 13x tends to 0. In this case, 7x tends to 0. Keeping in mind, we are taking 13x as, say, y, then limit y tends to 0 e to the power y minus 1 divided by y. That means value is 1 into 13. Therefore, finally, it will be 13 into 1 minus 7 into 1, 13 minus 7, that is equal to 6. See this. We need not write in each case the change of variable clearly. We can write it also directly. Here we find e to the power 13x. We keep in mind as 13x equal to y, then e to the power y minus 1, and I have written in place of x 13x into 13, at the denominator 13x, and the whole is multiplied by 13. Therefore, limit y tends to 0 e to the power y minus 1 by y whole into 13. Therefore, final result will be 13. Similarly, this will be 7. Therefore, finally 13 minus 7, that is equal to 6. The result is 6. Sum number 3. Given limit is equal to, I first write the numerator like this, limit x tends to 0 e to the power alpha x minus 1 plus e to the power beta x minus 1. At the numerator there is minus 2. I can write that as sum of minus 1 minus 1, and I take first minus 1 with e to the power alpha x and second one with e to the power beta x by x is equal to limit x tends to 0 e to the power alpha x minus 1 by x plus limit x tends to 0 e to the power beta x minus 1 by x. Now e to the power alpha x, I write here alpha x into multiply it by whole by alpha like this, and this is beta x, this is beta x, multiply whole by beta. You can write also the change of variable taking alpha x equal to new variable say y, and you can write that limit y tends to 0 e to the power y minus 1 divided by y whole into alpha like this. Therefore, finally alpha into 1 plus beta into 1, result is alpha plus beta. That is the answer. Next, number 4. I rub this one. Actually, this is also taken to the standard limit, but let me deduce this one. How we get the result? Number 4, limit x tends to 0, a to the power x minus 1 by x. Limit x tends to 0, a to the power x. If I write taking e as base, then it will be e to the power x log a minus 1. E to the power x log a, that is equal to a to the power x. Here I have written ln a. Note the symbol. ln a is equivalent to log of a to the base e. This one. Log of a to the base e is written in this form, ln form. Actually, this is natural logarithm that is represented by this symbol, which is discovered by John Napier. Log of a to the base e, natural logarithm ln a. Now, in place of x, I write x log a whole into log a. Now, limit y tends to 0 e to the power y minus 1 by y into log a. Here I have changed the variable taking x log a equal to y. Therefore, y tends to 0 as x tends to 0. Therefore, finally, this is standard limit 1 into log a log a. Therefore, limit x tends to 0, a to the power x minus 1 divided by x equal to log of a to the base e, or written in this form log a. This is also treated as standard limit. Now I move to number 5. Limit x tends to 0, numerator 2 to the power 3x minus 1, denominator 3 to the power 2x minus 1. Now, I shall use here this form, standard form, log of limit x tends to 0, a to the power x minus 1 divided by x. I write here this one will be treated after this as standard limit. Therefore, I write this limit x tends to 0, 2 to the power 3x minus 1 whole by x, 3 to the power 2x minus 1 whole by x. Here I have divided the numerator denominator by x. Can I do this? Yes. As x tends to a, therefore x is non-zero. I can divide both numerator by x. Mention here since x not equal to 0. Now this is of the form limit x tends to 0 fx by gx, that will be equal to limit x tends to 0 fx divided by limit x tends to a gx. Limit x tends to 0, 2 to the power 3x means 8 to the power x minus 1 by x by limit x tends to 0, 3 to the power 2x means 3 square whole to the power x means 9 to the power x, 9 to the power x minus 1 by x. That means of the form limit x tends to 0, a to the power x minus 1 by x means log of a, log of 8, and this is log of 9, and log of 8 means log 2 cube, and this is log 3 square, 3 log 2 by 2 log 3. Three log 2 by 2 log 3. Therefore, answer is this one. Let me check whether I have written correctly. Okay. Next, I have another one, number 6. For that, I just grab this one. Here I find x tends to 2, and at the denominator there is x minus 2. Therefore, we have to change the variable. Put x minus 2 equal to y. Therefore, y tends to 0 as x tends to 2. Therefore, given limit is equal to limit y tends to 0, x is equal to y plus 2 e to the power y plus 2 minus square by y. Limit y tends to 0. This is e to the power y into square minus square by y. Square is the common factor that is taken outside square into limit y tends to 0 e to the power y minus 1 divided by y. Therefore, this is square into 1. The result is square. I have worked out so many sums. On next standard limits, in the next class I will work out more sums on other two standard limits.